Adaptation and Policy. Bill Gates argues that we must do everything we can to reach net zero emissions by year 2050. Whether we reach this goal or not, the Earth will likely keep warming up, at least for some time. As you would remember, the global average has already increased by 2 degrees Fahrenheit in the last 100 years or so. What will happen in the coming decades is harder to know for sure, in part because we don't know how fast we can reduce our net emissions, or even whether we can reduce them at all or not. In the best case scenario, the Earth will warm up another 1 or 2 degrees Fahrenheit by year 2100. In the worst case scenario, we might be looking at a complete ecological disaster. Whatever the precise amount of warming ends up being, one thing seems prudent, if not, it is a matter of necessity. We should adapt to a warmer world. There are different ways of adapting, and a complete adaptation might require us to have a comprehensive approach. For instance, we must rethink where we build our homes and businesses. Some places that used to be viable locations for our towns might not be viable anymore. We could already see this transition happening. Places like New Orleans, for instance, may not last much longer. Another example is Bangkok, the capital city of Thailand. It is booming with a population of 10 million. Unfortunately, soon the boom might turn into bust. This is a map of the city showing the areas that are predicted to be struck by annual floods by year 2050. Unfortunately, the problem doesn't have an easy fix. Bangkok was built on marshland and permeable soil. Even if you try to wall off the ocean, the floodwaters would seep from under the city. What's more, those fancy skyscrapers in the picture are adding weight to the downtown area, which is gradually sinking the city into the ground. This is happening at a rate of 1 to 2 centimeters a year, which is about 3 to 7/8 of an inch in freedom units. So for Bangkok, there might not be much hope. Hundreds of thousands of houses and businesses might have to be relocated. I'm linking in the video description a short video about the sinking and flooding problems in Bangkok in case you want to learn more. Bangkok and New Orleans are extreme examples, of course, but the lesson can be generalized to most cities along the ocean coastlines. Many of them might either have to migrate inland and to higher ground, or take extreme measures such as building extensive ocean walls to prevent flooding. But even some cities that do not lie along the ocean and are never hit by hurricanes are susceptible to an increased flooding threat due to climate change. Take Chicago, for instance. Since Chicago is built on soft clay, most buildings and houses have basements. The problem is, rain patterns are changing due to climate change. Torrential rain is becoming more common in the Lake Michigan area. Whenever this happens, the city's 100-year-old sewer system gets overwhelmed, and sewage water starts backing up into people's basements. If you are lucky, it will stop at the level you see in this picture. If you aren't lucky, it would be waist high. There is an easy fix for this problem: installing a one-directional valve in the sewer pipe between the house and the main lines under the city. Installing these valves costs a few $1,000s, but could prevent damage anywhere between $10,000 to $50,000, not to mention your basement not filling up with poop water. Why don't everyone do it then? Some new homeowners aren't aware of the danger. Regulatory hurdles is also an issue. Getting these valves installed requires a cumbersome permit process to be followed. And finally, the same economic cost-benefit reasoning I described in the last lecture when I talked about why most people don't switch to efficient electric heating also applies here. Owners reason that flood insurance could be cheaper in the short term. Renters don't have any incentive to make long-term investment. So, most people either get flood insurance or cross their fingers. But they shouldn't have to. We should have a more streamlined permit process and even perhaps rebates for homeowners to install these preventive measures. Long-term return on investment here is so large that it makes no sense to wait until the disaster strikes. Speaking of flooding, we should also take care of natural flood barriers. For instance, mangrove trees. These trees are adapted to salt water, and their roots can provide natural barriers against ocean water flowing inland. Unfortunately, mangrove trees around the world are being destroyed as we speak to make room for fish and shrimp farms. To restore and protect mangrove forests, we need to eliminate aquaculture near them or switch to sustainable methods. Another natural flood barrier is soil, because soil can absorb water. Unfortunately, cities and road networks pave over soil. There are available solutions to this problem, such as permeable pavements and other materials that help soil retain its shape and absorbency during a flood. The problem here, as you can guess, is the high green premiums. So we must find a way to reduce these green premiums, reduce the amount of pavement we use in our cities, and switch to permeable materials. Another important form of adaptation is disaster readiness. There is some evidence indicating that a warmer climate will lead to more frequent and intense storms, although later in the course we will discuss a scientist disputing that evidence. In any case, we can't just wait and see whether these storms will arrive, because if we do so, it might be too late to do much about them. We need to have effective mitigation, preparation, recovery, and response policies in place. For instance, to mitigate flood damage, we need to prohibit new construction in flood zones and install preventive systems such as the backflow valves I described earlier. In order to prepare, we need to have emergency action plans, personnel, and supplies ready at all times. To respond, we need to have the will and ability to act on these plans. And to recover, we have to have the human and material resources to rebuild, treat, and repair. A specific form of readiness is making infrastructure more resilient. Every year, American Society of Civil Engineers evaluates the country's infrastructure in detail. At this point, most of the infrastructure in the United States is aging and vulnerable to natural disasters due to severe underfunding and insufficient maintenance. Stormwater systems, for instance, receive $250 million in federal maintenance funding annually. The problem is that it's only 3% of the funds needed just to comply with the current code. I'm linking ASCE's 2021 report about a few key infrastructure items in the video description. Assuming that necessary funds can be procured, one thing we might have to do is building ocean walls to protect the coastal areas that are most vulnerable to rising sea levels. Unfortunately, ocean walls aren't a magic solution. First of all, they are expensive. Besides, they are made mostly of concrete, which is, as you know, a major source of CO2 emissions. And finally, ocean walls might not even cut it, depending on the geological conditions on the site. As I pointed out earlier, they don't do much when the soil is permeable. Nevertheless, one thing that is certain is this. In order to adapt to a warming world, we need to improve the resilience of existing infrastructure and add more infrastructure to protect the areas that we can. The last item on the list is geoengineering, which can be seen as a stopgap measure or a last resort, depending on your perspective. Geoengineering is the deliberate large-scale manipulation of the planetary environment to counteract anthropogenic climate change. There are two types of geoengineering. First, there is capturing and sequestering the atmospheric carbon dioxide, which means pumping the captured carbon dioxide deep underground or into the ocean beds where it will become solid due to high pressures. A second approach aims at reducing the solar energy reaching the Earth's surface. The ideas here range from making land and ocean surfaces more reflective to putting a giant shade in space to block some of the incoming sunlight. The most feasible among these, however, involves spraying fine sulfur dioxide particles into the upper atmosphere to reduce the solar energy reaching the Earth. This is, relative to the costs associated with other things we have to do to reach net zero, is practically free. We could do it for tens of billions of dollars per year as opposed to tens of trillions of dollars. The catch is, we will have to keep doing it. And the more carbon dioxide we emit, the more we will have to do it. And if we stop doing it at any point, climate change might come back with a vengeance, significantly accelerating beyond the current rate. In case you are curious about this, I'm attaching a scientific paper examining such a scenario. As you can imagine, there are serious issues with geoengineering ideas. Part of the difficulty is geopolitical. How do we get different countries to agree about what to do? Suppose the United States decides to put a giant umbrella in space and India doesn't want it because it will reduce the sunlight their crops will receive. How do we resolve such a dispute? What's more, some countries are likely to be affected by climate change worse than others. For instance, low countries in Europe, the United States and China are looking at great harm to their economies. But Russia and Canada might even benefit from Earth becoming a few degrees warmer. The bottom line is, we don't have an international law framework that gives any country or set of countries the authority to conduct geoengineering, nor is it prohibited. For all we know, Bill Gates could decide to fund a space umbrella as a private individual, and as long as he procures the necessary permits from the country where he will launch his payloads, he can do whatever he wants. There are also moral issues. One thing some people bring up against geoengineering is that it's a form of playing God. Do we have a right to fiddle with the forces of nature? You can pitch the moral argument in purely environmental terms as well. The Earth is a complex system. It's hard to predict what exactly will be the consequences of a geoengineering attempt. For instance, some scientists think that solar dimming might accelerate ocean acidification and lead to a mass extinction event in the oceans. What's more, geoengineering could prolong our dependency on fossil fuels because governments and taxpayers could see it as a long-term solution to climate change. This could prove disastrous in the long run. If we extract and burn all the fossil fuels in the Earth's crust, the planet might never recover from the change. And we can generalize this concern and then turn it into an argument against all forms of adaptation to a warmer world. Here's how the argument goes. Adapting to a warmer world will undermine the efforts to prevent and undo environmental degradation. And preventing and undoing environmental degradation is better than adapting to its effects. Therefore, we should reject adaptation and instead focus on preventing and undoing environmental damage. The first premise of the argument is an empirical hypothesis. So, to decide whether it is true or false, we need evidence. Unfortunately, we don't have much evidence to go by here. The second premise also depends on some empirical facts. For instance, if adaptation will cost substantially less and save substantially higher numbers of human lives, isn't that better than prevention and mitigation? Not necessarily, because someone who rejects anthropocentrism could argue that what matters is not only or primarily human lives and human interests, but the health of the global ecosystem or the survival of as many organisms or species. Such a person could claim that prevention and mitigation of environmental degradation would be better even if it would come at a great cost to us humans. So whether we think that the second premise is true or not depends partly on empirical facts and partly on the moral framework we are operating on. But what do you think? Is adaptation a good idea? Or is it a distraction? This brings me to the end of this lecture. Send me a message if you have any questions. Thank you for your patience, and I'll catch you next time.